Our topic for today, we are looking at free radical substitution. So this is AS level chemistry, unit 1, part of the organic section. The reason we're doing free radical substitution as opposed to any other of the organic reactions is that it is a huge thing. It's worth a huge amount of marks if this comes up in an exam. You could be looking at 9 marks, all right? So it's something that you have to understand, you have to be able to do, and you have to be able to apply. So we're going to look at some easy things first. So free radical substitution is the name of it. It is always to do with an alkane, so any alkane, including methane, plus a halogen. And the halogens we look at here are either chlorine or bromine. Fluorine is far too reactive to take part in this reaction, and iodine is not reactive enough. So you'll either get chlorine or bromine, and they behave in exactly the same way, as do methane, ethane, propane, butane. They all react in exactly the same way. The 3 steps you need to be aware of, we have got the first step called initiation, the second step called propagation, and the third step called termination. The one that people find tricky is propagation, but we are going to go through all 3 of them today. So we are going to look at an example. So we're going to look at an example. We'll take, if we've got, let's do ethane. So we're going to have CH3, CH3. Let's add it to chlorine. The product that we're going to make, overall this is, so without first of all even looking at the mechanism, we are going to make we're going to make chloroethane, and we're going to make HCl as well. This equation is already balanced. This is our generic equation with an interruption by the technician there. Okay? However, we need to know in much more detail than that. This whole reaction is called free radical substitution. Okay? Our free radical here is going to come from our chlorine. So we have a Cl2 molecule. It is a diatomic molecule. That is very stable. It's not going to do anything at the moment. What we need to do is make free radicals. So how we do this, if we can see it, how we do this, let's do it down here, is we're going to shine some UV light onto our chlorine molecule. And that is going to break it up into two chlorine-free radicals. Okay? These arrows here, these sort of half arrows, show the movement of electrons. If you have done some work already, I can tell you, and you should be able to tell me, that these arrows here are showing homolytic fission. Okay? The chlorine, one electron from this chlorine, one electron from this chlorine, is moving to break up this bond. So we are left with chlorine-free radicals. This chlorine has got 7 electrons in its outer shell, and this chlorine has got 7 electrons in its outer shell. It is not called an atom, even though technically it is, because it has once been a chlorine diatomic molecule and it's been split up. Alright? It is definitely not an ion. There is no charge on this. Each of these has not gained an electron. These are free radicals. And this is our initiation stage. That is it. Okay, so our conditions, we need UV light. We draw UV light as a little squiggly arrow like that. And we make our chlorine-free radical. With that chlorine-free radical, free radicals are so reactive, they are desperate to react. So now we can start our propagation stage. So, we are adding it to ethane, So, the way to show this, to show exactly what's going to happen, we don't want to write CH3, CH3, because that's very difficult for us to draw a mechanism, and often you'll get asked to draw a mechanism. So, we write it as this. This is still ethane. 2 carbons, 1, 2, 3, 4, 5, 6 hydrogens. This is ethane. All we have done, we've separated one of the hydrogens, because this hydrogen is going to be involved in the reaction. we're going to add it to our chlorine free radical. Okay, we are going to make a carbonyl free radical, which is here, and we're going to make HCl. This again is completely balanced as an equation. All we need to do now is show what exactly happens, what happens. This chlorine here has obviously gone to make this HCl here. So it's going to be making a bond, this chlorine, with this hydrogen here. So this bond needs to be broken. And the way that we show that is that one electron from the covalent bond moves back onto the carbon. One electron will move to the middle, and one electron from the chlorine will move there. This is showing that a new bond is going to be made between the HCl, and this bond here is going to be broken. Okay, what I should have said first of all is this is our, I put it over here, propagation. Okay, this is not what we want though. We do not want to make a free radical. The whole purpose of free radical substitution is to make an alkane that's been added to a halogen. This is still an alkane. It hasn't been added to a halogen yet. So our next step this is our propagation step 2. Our next step is we take the carbonyl free radical that we've made. So we've got H3C, H2C. Okay, that is a free radical. We need to add it to something that isn't a free radical. In this reaction, we haven't just put in one molecule of chlorine. We put in a whole host of molecules of chlorine. So what we can do is add another chlorine molecule. This is just showing the bond between a Cl2 diatomic molecule. Okay, what we want to make at the end if we can see that. What we want to make at the end is this. Okay, and the way that we show that is that there needs to be a bond created here between a C and one of the Cl's, and this bond here needs to be broken. So again, we use these half arrows because we're only showing the movement, or should I do that a bit bigger, the movement of one electron at a time. So we've created a bond here between the C and this Cl, and this Cl is then left by itself. This Cl2 molecule has undergone homolytic fission again to create a Cl free radical. Okay, this here is our product. We've got 2 carbons, 5 hydrogens, and a chlorine. Okay, but we still have got this chlorine molecule over here. This means that this could carry on reacting if it wanted to, because we've still got a free radical. So that is our propagation step 2. What we need to look at now is what we can do to stop that reaction. What we can do. So there are 3 ways in which you can stop this reaction, and they all involve adding 2 free radicals together. So if we look back at the free radicals that we've got involved, we could have that could be one of our termination steps. We've got 2 chlorine free radicals that have been added together to make a chlorine. We have also got these 2 free radicals, which could add together to make hang on, we're running out of space. To make, if we do it very small, to make this, which if we know our naming right, this is butane. Okay? Our third free radical is we could mix these 2 together. So we could have Cl free radical added to our carbonyl free radical. Hopefully we can fit this in. And we can make this free radical. Okay? Oh, hang on. Getting a bit pen happy. CH2Cl there, which is our product. Okay? So we have done initiation, which is where we create our free radicals, propagation, which is where the reaction itself happens, and termination, which is where we have to physically end the reaction by putting two free radicals together to make a molecule that isn't a free radical. This is a substitution reaction because what we have done here is we have substituted one hydrogen from the ethane with a chlorine. We could carry this on. We could substitute another one of these hydrogens to make something like 1,1-dichloroethane. We could substitute one of these to make then, well, 1,1,2-trichloroethane. We could carry on. We could replace all of these hydrogens with chlorines depending on what we wanted to do. As I said, these are huge marks, huge number of marks if this question comes up. So hopefully this has been helpful.